I'm here to tell you a little bit about security. I apologize for my voice. We've been having such a good time here at the Miami Bitcoin Conference. Yeah, we're almost done talking. So, decentralized cybersecurity. There's an enormous challenge in this space, and it's caused by a very simple thing, which is we just gave you a key and we told you not to lose it. How's that going? Right? Well, it's a little bit better than we gave you a password. By the way, it's 64 characters long, and it's upper and lower case, and we change it every hour. That would be even more annoying. So, blockchain. Blockchain's secure, right? Well, sort of. So let me dispel a few myths. Blockchain is trustless. That's correct. There's no trust at all. I steal your private key, I'm you. Take any of the ICOs you hear in identity, security, information, VPNs, all that kind of stuff. We can have the world's greatest chain, but if I steal your private key, I'm you. There's censorship proof. Censorship proof is a really cool idea because we can stand up a chain, we can deploy it everywhere in the world, the Chinese can try and shut it off, and we can still use it. Well, that's cool, but the byproduct of that is that network security is censorship. Therefore, blockchains are network security proof also. That's a challenge if you want to put secure stuff on a blockchain. One thing it is absolutely is immutable. I can put data on the chain and it never changes. Problem is, I don't know whether you intended to put the data on the chain. So the chain's full of garbage that never changes. We just don't know whether the garbage actually came from you or not. We don't have any evidence if we look at a chain that this key in this condition with these controls wrote that data, or somebody stole it. So we can't tell the difference between a key held in Fort Knox and a key written on the bathroom wall. So the real challenge is, was the transaction intended? So what we're trying to do is bring a set of technologies to show that we can solve this problem. But let me talk about how we do that. So in the beginning, there's an instruction. An instruction is what a wallet creates. Please send this much money from this account to that account. By the way, that's what we've been doing for e-commerce for 30 years. Hasn't been safe in e-commerce, so hopefully we're going to make it safe in blockchain. What we know, if we look at anybody who's gone and looked at Etherscan and said, did I do that transaction? There's a transaction hash. You can click on the transaction hash in Etherscan. Up comes your transaction, and you can see this much money went from this account to that account, and you can keep clicking along, and you can watch where your money went after that or what before that. It's actually quite entertaining. All we know is the transaction hash. What we're trying to suggest is that we can add to that some information around the keys, rules the keys have to follow. A rule for a key would be, you can't use the key unless you know the PIN number. That's a simple rule. You can't use the key unless some other system says you can use the key. That's like a smart contract. You can even do that inside your device. So trusted execution is a technology that has been out there for 15 to 20 years now. It's in over 1 billion handsets, over 1.5 billion PCs. This is hardware security embedded in the chipsets that does, we in the industry called it trusted computing. It turns out it probably wasn't a brilliant name. I used to come from that space. I was part of setting the original standards. My team built a lot of the infrastructure around it, wrote a lot of the specifications. It's really measured compute. What trusted compute means is we run a whole bunch of stuff from the ground of the chipsets all the way up to some code running, and at the top we get a signature. Oh, it's like a Merkle tree. So each step you check the signature, and if you get to the top of the dozen steps and the signature is the same as yesterday, guess what? None of the steps have changed. And so we have an electronic signature, or a hash, that proves that that environment's running the same as it was before. And so we can begin to incorporate that, so we can say, these rules with these keys running in that environment were the same as they were before. And so a year ago, I was here at Miami Bitcoin. We showed the first transaction where we included an attestation hash on the chain embedded in a transaction. And so what that made possible is, for the first time, I can prove mathematically that this device with these controls in this condition did that transaction. So it's about improving the quality of the data that can be stored on a chain. So what are rules? Rules can be a PIN number, a biometric. Those are sort of human things you would ascribe to a rule. They can be verify the execution of is in a reference condition. We could have external controls. We could ask the little trust agent in the device to ask somebody else, like, where am I? So let's put a beacon on a nuclear submarine. We could say you can only spend the Bitcoin from the nuclear submarine. So the device, my mobile phone, could check with the beacon, am I in Bluetooth range of this beacon? If you're in Bluetooth range of the beacon, you can spend your Bitcoin. So we can put any control you want. You know, we could have a server that says you're only allowed to spend your Bitcoin when the moon is full. There are all sorts of interesting opportunities. You know, you can only send this tweet if everybody in the cabinet approves it. There are all sorts of things you could do with this. So this summer we did an ICO because we built a token around last year's Miami Bitcoin presentation that shows how we can build an economic to say we can ask any of these cybersecurity controls and we can incorporate a revenue model. So will you offer a control for me that I can ask if I'm allowed to do something? It can work with all of enterprise, all of cloud security. So this is how we build into the chain provable cybersecurity controls on a completely decentralized basis without central control. Well, there are some central controls. The owner of the platform is the central control. Turns out if mom owns a phone, it's centralized control. Mom's in charge. And we like that. Here's, I think, the really interesting point. If we could move and improve the quality of the data that's stored on a blockchain, then the value of the data that we can store on the blockchain goes up. And so there are lots of ICOs out there that would have some really interesting challenge in actually proving that the data stored on the chain is actually the data intended. And there are lots of applications where if we had cybersecurity controls, we could do things with chains we can only imagine today. A simple example would be, it's sort of an easy one to us describe. Like, imagine if we were trying to keep on blockchain inventory of all the bullets in the US Army. So you got 50 people making bullets, 9,000 people using bullets, and the Russians steal one key. How many bullets are there? I don't know. Because the Russians have been just diddling the number up and down every day, and we can't tell when we look at the chain from a transaction perspective how much is actually there. And so these are the kinds of things where cybersecurity controls could be wrapped around those keys, and we say, look, we keep getting these transactions that come from Moscow. Maybe we should wonder what's going on and who's shooting bullets in Moscow. So Rivetz is a company that's taking advantage of this embedded security. There are 500 million phones that have this chipset capability within them today that we have access to. We're building services and support and applications to help customers and partners take advantage of this. So ultimately, we're here to bring these tools so that anybody who builds an application, whether on blockchain or off blockchain, can take advantage of them and put them to work. So we want everybody to have their own effective key store. So if we can produce a hardware level wallet, we want to have as many different wallets as you want as part of it. There's trusted display on these devices. There's secure key storage. You have some really interesting aspects. Now, are they perfect? No. But they're measured. So we know they're the same as they were. And I think one of the really important things as you think about security is there's a continuum of how secure things are, and that security really becomes part of a measured environment, which is ultimately represented in a signature or a hash. We just actually are showing here, we just launched it the first of the year, an authenticator. We think this is one of the first experiences you can have with this technology. It'll become broadly commercial available later on this quarter. But this is just a Google authenticator, where instead of the seed keys sitting in your Android operating system, the seed keys are sitting in tamper-resistant hardware on the chipset of the same phone you have. And so you have the benefits of an isolated execution and protection of a key, but you don't have the inconvenience of, let's say, having an independent device like a YubiKey, which I have to carry around in my pocket. And so this is a simple example. One person can download this, one person can use it, and it's interoperable with everything from Gmail to Coinbase. We didn't have to talk to Gmail or Coinbase to make it interoperable. They support two-factor authentication. We just made two-factor authentication better. We're starting to mess around with things like backup and recovery because it shouldn't be about your super phone. Your super phone is like one device. What you really want is your collection of devices to be your identity. So when I back up a key, can I back it up to the rest of the devices in my household? If I'm going to generate 12 or 24 words, can I put those words shown on different devices so they don't ever appear on a single screen? So assuming somebody's scraping your screens, maybe I can send half the keys to my spouse. Maybe you don't trust your spouse. You know, humans are fun. It's really kind of fun to wrestle around like, well, we'll back it up and mom will have the keys. Yeah, well, what if mom's pissed at you, right? You know, or maybe you have to call mom and mom has to push one on the phone to release your keys. Now, that'd be great because mom would be all over that because you never call mom enough anyway, right? So there are all sorts of opportunities to leverage sort of this social encryption model of how we manage and recover keys. Security needs to be built in by design, not something you add on later in life. We know this. So, this is a simple magic trick. I can guarantee you, think about the favorite two-factor authentication system that you use. Everybody's used a bunch of them, from SMS to Google Authenticator or whatever. I guarantee you're all wrong. That your favorite, that you think is your favorite, is not the one you use the most, and you don't understand what it is. Your favorite two-factor authentication is the send button on your phone. You dial the phone number and you push send. Underneath the send button is a $10 billion industry in the SIM chip that secures your relationship with the carrier, that's protected your keys. That when they deployed it in 1994, we got rid of passwords for every long-distance phone call. And if you look at a chart of the carriers, the value of the subscriber has done nothing but go up every year since they deployed it. So hardware security is important. It's not about security. Nobody cares about security. What we want to do is increase the quality and value of information we can deliver to you. That is what's important. We think about security as risk. And yes, there is a part of that that's true. But if we think about security as delivering enhanced quality or better experience, security is a user interface technology. Security needs to be built in. To that end, actually, one of the things we're announcing here at the show today is that Polyswarm and us are forming a consortium around decentralized security. We have a couple of other people that are also working to join us. We really would like to bring a broader community to this. This should be built into every chain. We did a demonstration a year ago where we hacked up Bitcoin to just show we could do it in the lab. Not because we were trying to change Bitcoin or get the core devs to make a change. We used checksig from Stack, which they should go add back to Bitcoin. That'd be fun. But the point is we could demonstrate that we can incorporate cybersecurity controls with really strong privacy embedded into the chain to improve the quality and value of data that we can store in this whole ecosystem. Because there's a lot of cells out there that have data in them, and we want to increase the value of what they store. So we're a utility token. We are going to try and be the poster child for a utility token. This is how we deliver value. This is how we operate our service. Every one of the people who bought tokens in our sale can use them. Because every one of them bought them with Ethereum, guaranteed they have Ethereum somewhere on an exchange or in an account. All of them could benefit from greater security in two-factor authentication to their exchange. So we're trying to build a solution that everybody can use. We're trying to deliver provable cybersecurity controls, ones where you can validate that the security was in place. And ultimately, I think if it's successful, one of the great challenges we have is we want to give our robots money. We want them to buy VPN services, we want them to buy more data. Maybe I can order a customer support call and have them send me a new battery with a guy to put something in. You know, there's all sorts of things that are possible in the future. How's your device going to spend automatic money? Because if you give your device money and say, hey, you got $5, spend it on anything that comes by, you're going to lose all your money because your robot's going to give it away. What we need is a policy fence that is controlled by the owner of the platform that says you're only allowed to buy milk with your money or whatever service it is. So we need controls around automatic money. I think it's a really important piece that will make the whole process of these tokens for utility simpler in their execution. You don't want to have to get your Trezor out every time your device calls up and says, hey, get me some 3 cents worth of VPN services because I want to call somebody else. And can you please type in your key? This is like having a girlfriend who likes to talk a lot and a payphone. It's like, put the quarter in. She's still talking. You're just putting quarters in. I'm old enough. I used to use payphones with quarters. So this is ultimately about increasing value on the blockchain. So with that, we'll wrap up. I want to say that security is something that has to be built in. It's not added on. Today, we're adding it on. Buying a ledger, buying a Trezor is adding it on. It's not built into the blockchain. We have this fantastic ecosystem that's built on securing the information of the transaction, but we haven't added a layer to it that allows us to capture the cyber controls. Do you have to use it? No. But if you do use it, I think we can dramatically increase both the simplicity and quality of the transactions that are executed. And we have to move towards much greater consumer market model for this. We have to make it easy to use these systems and make you feel safe when you are using them. And so that's what Rivetz is all about. Thank you very much.